mentioned, I've spent the past 3 years of my career almost solely dedicated to blockchain technology. So obviously this is my favorite thing in the world to talk about. Thank you for making my morning. I really appreciate it. So maybe just 30 more seconds on what it is I actually do at PwC. So as part of our new services and emerging technology practice, I really have 3 responsibilities. So the first is I'm fortunate enough to get to work with partners, directors at PwC who spent decades in a specific industry, working on a specific process area, and I get to spend a lot of time with them, talking to them about emerging technology, learning about what they do, teaching them about our digital toolkit, and working with them to actually find technology solutions to real-world problems. We then take their ideas for potential solutions, and then we actually build things in our emerging technology lab. So we build proof of concepts and prototypes that actually test these technologies and also show us what these technologies kind of look like and feel like. And then the last thing that I'm responsible for in the lab is we actually are responsible for training PwC on what emerging technology is and what blockchain is. So our metric for the end of the year is to have every single person at PwC trained up on blockchain. So that doesn't mean we want thousands and thousands of auditors learning how to code. That's actually kind of a nightmare. But what we do want, right, is every single person at PwC to be able to understand what blockchain is, when it might apply, and when to actually work with our team to find a solution to a real client problem. So I'm going to start with something you already know, and it's that innovation is essential to every single business today, right? Every year PwC does a CEO survey, and we find out that at least 60% or 70% of CEOs are worried about technology and its impact on their business. Adoption is actually moving much, much faster. Companies are finding that they can no longer wait to implement new technology. So that's where we come in, right? We come in with this notion of a digital transformation. And what that means is not just throwing technology at a problem. You never ever want people like me sitting in a basement trying to figure out how to use blockchain to reform the healthcare system. I have no idea how the healthcare system works. It's never going to work. But what digital transformation actually does mean for us is thinking about what outcomes we really want to achieve, whether we want to achieve efficiency, whether we want to break into a new growth area or a new business opportunity. And it means working with companies to actually think about how technology fits in their overall business strategy and how they can think differently, work differently, use their existing data differently to drive change. So that's the way that we set up almost every single presentation we do, and that's the lens that I hope you take when I talk about what blockchain is. So as Bernie mentioned, right, blockchain is just one of the essential technologies that we think are going to fundamentally change the way that our clients do business. So these are essentially technologies, and on their own, they add value. But when they're combined, when we actually think of these technologies as all just pieces of a digital toolkit, that's where innovation really does happen. So what exactly is blockchain? So as Bernie mentioned, it's more than just Bitcoin. I still have to tell my parents at every single holiday that I'm not just doing that Bitcoin thing. I think they're selling illegal drugs through Bitcoin, and I have to convince them that that's not the case. So if we think of blockchain as the internet, then Bitcoin and cryptocurrency is email. It's the first killer app. It's something that this technology is known for, but it is absolutely not the same thing. So what is blockchain? So all blockchain really is a shared digital ledger. That's it. But it's got a couple of features that make it a little bit cooler than that, right? So first of all, it's distributed. So not only is it a shared ledger where everyone's seeing the same information updated in real time, but instead of that functioning as a central database, there's actually no one owner. Everyone in the blockchain network actually owns a piece of the ledger. It also means that there's no one single point of failure. It's also cryptographically secured. So as we're sharing information across multiple parties on our shared digital ledger, we know that that information is encrypted, and we know that that information can only be seen and reviewed by parties who leave permission to see and review it. It's also consensus driven. So this means that the network has to agree before any information is added onto the blockchain. So that doesn't mean that every single person in a network has a physical human raising their hand and saying this information can be added. But what that means is we set up business logic for our blockchain. And computers actually have to agree that information is being added by the right people at the right time with the right permission to do so. What consensus also means is that the blockchain is immutable. That's the other word we hear associated with blockchain fairly frequently, right? We can only ever add information to a blockchain. We can never delete it, we can never tamper with it, we can never edit it, we can only ever add to it. And what the consensus of the network does is it ensures that information is only ever being added to the blockchain. So the only other point that I'll just pause on consensus and say is that when we talk about Bitcoin and we talk about cryptocurrency, we hear a lot of terms like proof of stake and proof of work, and we hear that that's really energy intensive, and we hear that that's actually slowly killing the environment. And the big distinction I want to make is that when we talk about cryptocurrency and we talk about Bitcoin, we're actually talking about a public ledger. We're talking about a network that's open to the world. And so because of that, consensus becomes a whole lot more difficult. When we talk about blockchain for enterprise, we're talking about a permission network where we know every single participant on the network. And because of that, consensus can take a much simpler form. So finally, when we know everyone in our network is sharing information that's updated in real time, we know everyone has the most accurate, up-to-date version of information, we know it's cryptographically secure, we know that that information is immutable and hasn't been tampered with, we can actually automate on top of that. And we can do that with something called smart contracts. They're neither smart nor a contract. So the name obviously makes a ton of sense. But all that means is when a network has agreed that they have the most up-to-date version of information, we can actually automate on top of that. And that's where blockchain becomes really powerful. It serves as a base for process automation. So I'm going to pause here and tell a story. So about 3 years ago, a very large industrial products company actually came to us, and they said they had a $2.6 billion problem. They had $2.6 billion in unpaid invoices. And it wasn't because their products were faulty, it wasn't because their counterparts didn't want to pay them. It was simply because the purchase orders and the purchase order data that they were holding in their ERP system didn't match the information that their customers had. And because of that information mismatch, they wouldn't realize that an invoice was past due until it was over 30 days past due, and then they'd have to manually reconcile that information. They'd have a cost center of people calling up a customer, asking why the invoice wasn't paid, sending PDFs back and forth of their purchase order examples, of their purchase orders that they had in their systems. When you take something like blockchain, right, and instead of each company having one version of a purchase order in their ERP system, with blockchain there's only one purchase order. Everyone has the same information updated in real time because there's only one copy of the information. And that's where blockchain becomes really powerful. It becomes really powerful when we're dealing with processes where multiple parties, multiple organizations are constantly reconciling information. Blockchain gets rid of that because there is only one copy of the information. So hopefully by now we're thinking that blockchain is cool. I hope. Hopefully by now we're thinking that maybe there's some real world applications for it. But that's only the beginning, right? What makes blockchain really, really cool is when we combine it with other technologies. So when we put blockchain in the context of artificial intelligence and the Internet of Things, we can actually automate trust. So I'll get to what that means in a second, but that's where this becomes really, really cool. So let's first talk about how these three technologies work together. So blockchain, as we know, right, it's the shared single source of truth. What the Internet of Things does, right, what our IoT-enabled devices, like our cell phones in our pockets, all do, is they connect our physical world with our virtual world. So IoT is a mechanism for data intake, whether that's you taking a photo with your cell phone and uploading it to the cloud, or whether that's an IoT sensor on a shipping container. IoT connects our physical world potentially with the blockchain ledger. So when we have that physical world information on a shared, immutable, distributed ledger, we can do some really cool things with that. We can then start thinking about AI and analytics running on top of the blockchain and taking that better data to then run much, much cooler processes or algorithms. So I was in Dallas a couple of weeks ago and they told me I had to come up with an oil and gas metaphor for blockchain. And I knew nothing about the oil and gas industry, and I actually had to Google what an oil rig was. But here's the analogy I came up with, and it seemed to resonate, so hopefully it resonates with you as well. But if we think of data as the new oil, right, because that's something we hear a lot, data is the new oil. So if data is the new oil, then blockchain is the pipes, IoT is the oil rig, and then AI is the car. AI is that thing that magically goes based on the oil in the pipes coming through to it. So now back to automating trust. So our exam question for the day is, well, in what situations do we need to create trust in a room full of strangers? And in what situation is the cost of trust really high that we would want to automate it? So we've got two different examples. So the first is this notion of trust in people. So in contractor-heavy industries, like the utilities industry, they actually are constantly faced with situations where utility companies are standing in rooms full of strangers. So when a natural disaster hits, hundreds and hundreds of contractors will typically flood a disaster site, all looking for work for a utility company to put up down power lines and to fix whatever the natural disaster has caused. What that utility company has to do is they have to then rapidly onboard every single contractor that's come to them, verify their credentials, and then put them to work. Typically, all of these contractors will have likely worked in the state before, they would have likely worked for a competitor utility company before, they might have even worked for that utility company before. But that doesn't matter. The utility company has to verify every single contractor's credentials, and they have to then make sure they're putting them in the right job. So today, that's a very, very manual and expensive process, and it's expensive for three reasons. The first is, an army of HR representatives checking contractor credentials is costly. There's also a really big opportunity cost there, right? If we're dealing with down power lines, if we're dealing with a hospital that doesn't have power, wasting a day onboarding contractors becomes pretty unacceptable. There's also the cost of getting it wrong. If a utility company onboards contractors who are actually not certified to do a specific task, they'll be hit with really, really heavy regulatory fines. And they also might have to do rework. What I learned the other day is that if someone who's not certified to draw a chalk X on the sidewalk draws a chalk X on a sidewalk, and then someone else who is certified digs up where that chalk X was, puts in a new pipe, covers it up with gravel, and then the utility company finds out later that the person who drew the chalk X wasn't certified, they actually have to go back and redo that process. That is incredibly costly and probably pretty inconvenient to everyone who lives in the neighborhood. And so finally, there's also the cost of having the wrong contractors do the wrong thing. Right, so again, when these utility companies are standing in a room full of strangers, they're trying to just get people quickly deployed to do a certain task. They're not really thinking about how to optimize scheduling. So if we have people in a room who are electrical engineers and are also certified to draw chalk X's on the sidewalk, and then people who are just certified to draw chalk X's on the sidewalk, we want to make sure those electrical engineers are saved for electrical engineering tasks and are not running around with chalk. So with blockchain, IoT, and AI, we can actually automate that trust and fix this problem. So with blockchain, what we can actually allow contractors to do is we can allow contractors to have a single digital enduring identity. So what that means is we can actually allow contractors to onboard themselves once and have their identity follow them from utility company to utility company. So similar to the way that we actually are onboarded to something like TSA PreCheck or Global Entry, utility contractors can create a profile for themselves, go to an industry authority, an industry standards body, in my analogy, TSA. They can prove their identity, they can compare their profile to the physical person in front of them, to their government-issued ID, and get onboarded into the system, right? We can then allow utility companies to verify the certifications of these contractors once, and those certifications will forever live on the blockchain. So now as they move to the next utility company, because the first utility company verified them, that second utility company knows that they're certified to do a certain task. And each utility company can keep adding to that digital record, right? So as contractors are certified to do new things, as they complete new tasks, all of that can be continuously added to the blockchain. So blockchain proves contractor credentials. So where does IoT come in? With IoT devices, we can allow contractors to onboard almost instantaneously. If a contractor has a cell phone with a QR code that links to their profile and a government-issued ID, they can go anywhere. They can go to the middle of the ocean on an oil rig, have someone scan their QR code on their mobile app, look at their government ID, see their profile, really similarly to how we go through TSA at the airport, and they can get immediately onboarded to do a task. We can also even use things like facial recognition for these very same contractors. So then, once we have that information, right, we know who our contractors are, they're onboarded onto a utilities company's program to respond to a natural disaster, we can use AI for schedule optimization. We have all the information about who are the strangers in the room who are no longer strangers, and now we can optimize the tasks that they're doing. So I've got one more example, right? So trust in supply chain. We talked about trust in people. Now we want to talk about trust in things. So I recently read a stat that there was something like $74 trillion in counterfeit goods globally over the past year, which is frankly pretty terrifying. So we end up in these situations where throughout our supply chain, at some point we have a bad actor, and at some point something happens that we don't have full transparency into. When we put our supply chain on a blockchain, we can retain transparency through our full supply chain. We can allow every single supplier that's contributing to a supply chain to actually add onto the blockchain what they do, when they do it, and how goods are transported between different suppliers to a manufacturer and to storefront. We can use IoT sensors on different shipping crates, on different manufactured goods, or even just cell phone scans to actually connect that physical supply chain onto our virtual blockchain. And then we can use analytics or AI algorithms to better optimize our supply chain, because now that we have all of the data around what's happening in our supply chain, when it's happening, how it's happening, who's doing it, we can then optimize, because now we have a whole bunch more information, and it's all stored in one central source of truth. It's not stored in disparate compliance documents. It's not stored in PDF purchase orders. It's all stored in one place for people to see. So I think I'm out of time, so I'll pause there. But hopefully this was interesting, and hopefully you've got questions for me.